Before we start today's class, let's begin by reviewing some concepts and words that will serve as keywords for our learning. They are solute, solvent, solution, dilution, and concentration. Solute is the substance that will be dissolved. In our case, the substance is usually in a solid state, such as a powdered medicine. Or it can be liquid, such as a medicine in a liquid state. Solvent, a substance that has the ability to dissolve other substances. It is usually a liquid, and in our case, it can be water, a saline solution, distilled water, or even a glucose solution. And a solution is the mixture of two or more substances. Normally, they are liquid substances with another liquid substance, or a solid substance with a liquid substance. In our case, it will be the mixture of the solute with the solvent. Dilution is the addition of a substance to reduce the concentration of another substance. In our case, we are adding a liquid substance, the solvent, to reduce deconcentration of a medicine. And finally, the concentration is the amount of solute that exists in a solution or solvent. So, now that we are familiar with all these concepts, we can begin our lesson. As mentioned, diluting means decreasing the concentration of a substance through another liquid substance. So, when we dilute a medicine, it means that we are decreasing its drug concentration using a liquid substance. For example, a vial of a powdered antibiotic has 100% of the drug concentration. This is our solute. By adding the saline solvent into the vial containing the powdered medicine, we are reducing its concentration. In other words, the mixed substance has now become a solution, which contains a lower concentration of the medicine. But a question remains. How much concentration was there before the dilution, and especially, how much concentration is after the diluted process? Here's where math and the medication calculations come in. And to do this, we need to set the values for each thing. Let's say that our antibiotic has written on its label that it contains 1,000 milligrams of the medicine in its current state. Note that it is in the form of a solid powder and does not contain any liquid. Therefore, the 1,000 milligrams are found without any liquid of measurement capacity. If we add 5 milliliters of a saline solution, the new solution we are creating will still have 1,000 milligrams of the medicine. However, now the concentration is diluted in the 5 milliliters that were added. But now, how many milligrams are in each milliliter of the solution? To know this answer, it is necessary to use the mathematical calculation of the rule of 3. We know that our antibiotic has 1,000 milligrams in 5 milliliters. The question we must ask is, how many milligrams the solution has in 1 milliliter? Remember that to set up the rule of 3, it is necessary that the quantities must be in the same column, as it follows: milligram with milligram, and milliliters with milliliters. The value we want to find is x. Now, we just need to do the cross multiplication, where the denominator on one side will multiply with the numerator on the other side. So, we have that 5 multiplied by x is equal to 5x's, and 1,000 multiplied by 1 is equal to 1,000. X then is equal to 1,000 divided by 5, which gives us the result of 200. However, it is important to remember that we are not just doing a mathematical calculation, but a medication calculation. Therefore, it is necessary to add the metric units of the value found. In this case, it is milligrams. Done! We then have that 1 milliliter of our diluted antibiotic is equivalent to 200 milligrams of the medicine. Next class we will continue the content and talk about the why do we dilute some medications and what is the dilution process. Don't forget to click the like button, leave a comment, share it with your colleagues, and subscribe to the channel, activating the notifications. Until next time.